Hello, everyone. Welcome back. Today, we're going to be talking about systems of equations where we have one linear and one quadratic. So, the first possible outcome is there could be no solutions, right? It could be the case that the linear and the quadratic never meet. There also could be one solution. They might meet in one place, like in the middle example right here, or they might meet in two places, meaning there would be two solutions. And so those are the possibilities of things that can happen when we have a system of equations involving one linear and one quadratic. So now let's solve each of these systems. So in terms of what techniques we're going to need to use to solve them, we're going to be using the same techniques that we used for solving two linears. We're going to be using things like substitution and elimination, especially substitution will be quite a common one for stuff like this. And we'll also be using our quadratic like our quadratic formula or other means of solving a quadratic, because that's what it's going to essentially come down to. So that's what we'll do. For this first one, I'm going to use substitution, which will be pretty simple because we have y equals something for the linear and also y equals something for the quadratic as well. So we can just say, well, then those two things must be the same. X squared plus 6x plus 5 must be equal to x minus 8. Then I'm going to add 8 to both sides and subtract x from both sides. So minus x plus 8 so that those cancel. And then minus x plus 8 on this side as well. And that's how I'm going to get x squared plus 5x plus 13 is equal to 0. Now at this point, we just have a quadratic that we need to solve in order to solve the system. So we can solve quadratics either by factoring, or by completing the square, or by using quadratic formula. Now, factoring doesn't always work, right? Especially because there could be no solutions, right? And there could be no real solutions, and so trying to factor isn't going to get us anywhere in those circumstances. So that leaves us with the quadratic formula or completing the square. Either of those will work to directly solve this problem, but I think that using the quadratic formula will be faster, but that said, you can use whatever method you'd like, and you'll still get the same answer. So I'm going to use the quadratic formula. So as a reminder, quadratic formula is that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is 1, right, because a is the leading coefficient, b is 5, and c is 13, right? Just looking at this equation and writing those numbers down. So therefore, x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 13 all over 2 times 1. And so therefore, x is equal to negative 5 plus or minus the square root of, let's see, 25 minus 13 times 4, so 25 minus 52, so negative 27 over 2, like that. And so therefore we have no real solutions, right? The second that we have a negative sign in our square root, that means we have no real solutions. Now we could go a bit further with this if we want to give the imaginary solutions, right? We could say it's negative 5 plus or minus 20 root 27i over 2. That also works as well. Okay, let's do the second one here. For the second one, the first step I need to do is I need to isolate for one of the variables so that I'm able to substitute. So I decided to isolate for y with respect to the first equation, which is our quadratic equation. And recall that x squared minus y is equal to 7 is the same thing as y is equal to x squared minus 7, right? So we're just rearranging this to isolate for y. Then what I'm going to do is I'm going to sub this into the second equation. So we have 3x minus 2 times x squared minus 7 is equal to 4. So then we have 3x minus 2x squared plus 14 is equal to 4. So then we have negative 2x squared plus 3x plus 10 is equal to 0. And then what we need to do is we need to use the quadratic formula, Or, I mean, we could also technically complete the square, although completing the square would be a bit of an ugly process here because there would end up being a lot of fractions and decimals we'd have to go with. So I think in this case, definitely quadratic formula is the way to go. So a is equal to -2, b is equal to 3, and c is equal to 10. So x is equal to -3 plus or minus the square root of 3 squared minus 4 times -2 times 10 all over 2a, like that. So we have -3 plus or minus the square root of 9, let's see, plus 80 over -4. So therefore it's -3 plus or minus the square root of 89 over -4. And so in this case, we would have two solutions because we have the plus version and the minus version.